Today we're looking at multiplying fractions and making sense of what it's really asking by using models to explain. Our first example is when we look at a part of a part. So we have something less than a whole of something else. And this is when we used our brownie pan method here, where we would start out with less than a full pan of brownies. So this square represents my full pan of brownies. We started out here with 1/4 of the pan full of brownies. So remember, the denominator tells us how many parts to divide this into. So I'm going to take my brownie pan and I'm going to partition it or cut it up into 4 parts. And the numerator tells me I need to shade one of those parts. So I don't have a lot of brownies in this pan, and it's represented here by my highlighter. The next thing that we want to do is look at this first fraction here, 2/3 of 1/4. So now what we're going to do is we're going to partition this the opposite direction. And again, the denominator tells us how many parts we need. In this case, we need thirds. And the numerator here tells me how many of those to shade, 2 out of the 3 parts. So I'm going to shade 1/3 of the pan. And there's 2/3 of the pan. Now I shaded some of the pan that doesn't have brownies. That's okay. I can shade the entire pan. And now for my answer, I'm only going to be looking at the same size pieces here that have double shading. That represents 2/3 of 1/4. So you'll see here I have 2 parts that represent the double shading out of a total of 12 equal parts in the whole brownie pan. So I like to shade the entire pan even though it doesn't all have brownies, because it allows me to divide the entire pan or the whole into equal size pieces, which I will need here for my denominator. So again, 2/12 represents 2/3 of 1/4, the double shaded part, which are the amount of brownies that I would purchase. The next one is a part of a group. We used an example in class with a block of cheese. A family ate a part of the block of cheese. Now the block of cheese weighed 2.25 pounds. So we need to figure out the units here, which are pounds, and we need to figure out how we are going to represent 1 unit in our drawing. So here's 1 unit, here's a second unit, and here's 1/4 of a unit. Now I could call these pounds if I had a problem that involved this, the weight of the cheese here. So if I want 1/3 of a 2.25 pound of cheese, I would need to take my model now and I would need to partition this into 3 parts. So each unit here will get separated into thirds, and the numerator here tells me I need 1 of those thirds. So I'm going to shade 1 of the 3 parts here. And then for my second unit, or my second pound, I also need to partition this into 3 parts and shade in 1 of them. And finally, for my 1/4 unit, or my 1/4 pound, I also divide that up into 3 parts and shade in 1 of them here. So my answer now here are the shaded parts. But you'll need to be careful, because when we give our answer, we need to be giving it in same size pieces here. So this is 1/3 of 1/4 here. So if I were to actually draw out this full pound or full unit, let's see here. We actually have a total of 12 parts here that represent that whole. So this shaded part is 1/12. And if I divided this into 12s too, then 1/3 is equivalent to 4/12, and the same thing here. 1/3 is equivalent to 4/12. So when I add up those shaded parts, 4/12 plus 4/12 plus 1/12, it gives me an answer of 9/12 here, and that's my answer. And you can reduce this. They both are divisible by 3, so we could write this as 3/4. The last one is a group of a group. So here we have this mixed number 2.5 of another mixed number 6 1/3. This one, I like to think of it as I have 2.5 groups of size. In this case, the size of each group is 6 1/3. So I've created one group here. This represents 1, 2, 3, 4, 5, 6 1/3 of a group. Here's my second group, also of size 6 1/3. And then I have a third group of 6 1/3. But remember, I don't need 3 groups, I only need 2.5. So I've sliced this in half with my dotted line there. So what I'm really looking at here is everything here that I shade. This will give me my answer. And the problem that we looked at in class talked about harvesting corn. It said that you could harvest 6 1/3 acres of corn every day. How many acres would you harvest in 2.5 days? So this model would represent that problem. And now we're just going to have to add up all of the shaded parts here. And we're going to have to be careful because they all are different size pieces. But we can handle that. I have, let's talk about the whole pieces that I have first. So I have 2, 4, 6, 8, 10, 12 whole pieces. Plus I have 1, 2, 3, 4, 5, 6 half pieces, or 6 times 1/2, which gives me 3. And then I have over here, I have 2 pieces that are both size 1/3. If I add those together, that's 2/3. And then finally I have this little guy over here, which is not 1/3, but half of a third, or 1/6. All right, so now we're ready to add this up. 12 plus 3 is 15. And then, I don't have like denominators, so I have to scale this up by a factor of 2 and turn my 2/3 into 4/6. So I have 12 plus 3 is 15, and then 4/6 plus 1/6 equals 5/6. So in this problem, I can harvest 15 5/6 acres of corn in 2.5 days.